Guys, just like the previous classes, we'll do some of the numerical problems itself. Regarding this chapter, I have told you there were lots of questions as asked for your school examination point of view, as well as NEET, as well as KEAM examination. This chapter is very important, guys. So we'll go with the first question. So let's do the 94th question, guys. So what is the question mentioned? It is said that two stones are thrown from the top of a tower, one vertically upwards and the other vertically downwards. With it is thrown, okay, so some velocity will be there, okay, and one vertically upward and the other vertically downward with same speed. Ratio of the velocities when they hit the ground is asked, right? So again, so like what was the question number? It was 94. Let's take another color. It was 94, right? So 94th question, how will do? Now let's draw a platform like this, right? So let's say it is, this one is our ground, right? Let's say this platform is a height of h. Now set the tower, right? Let's say this is the tower and the tower B is having a height h. As a stone is thrown vertically upwards, will come to the point of projection itself, right? See, if this is the velocity, if this is the stone, let's say that is a stone or ball whatsoever, I'm throwing it, then this has to reach the ground like this, right? So this which I have drawn as this line is its mean position. So I am trying I threw this first ball with the velocity u1, right? So this u1 is in above direction, but when it is reaching this point, then here also it will have a velocity u1 but in downward direction. So this is positive, means this will be negative, that's the difference. But at this point both the velocities will be having same value, right? And now this u1 is in this direction, clear? Now the ball will be here now. So when we say this ball, let's say v1 is the velocity when it is dropped or when it has reached the ground. So I will write v1 squared is equal to u1 squared, right? See, downward direction means I have to take it as minus u1 squared, right? So v1 squared my is equal to v1 is in downward direction, so this will be also minus, right? And g, right, g is also minus, so I will write it as minus 2gh. So minus everything can be removed, or I can write v1 is equal to root of u1 squared plus 2gh, right? Let's keep that expression. Right, now let's regard the second stone. The second stone is thrown downwards, right? This is the second stone. This stone is directly thrown downwards, let's say thrown with the velocity u2, that is in downward direction. Alright, so let's say when it reaches the ground, its velocity is v2. So v2, again I can write it as v2 downward, so minus v2 squared, right, minus u2 squared minus 2gh, right? So again I can write v2 is equal to root of u2 squared plus 2gh, right? And you have been told in the question itself, both are thrown with the same initial velocity, means u1 and u2 same. So u1 and u2 are same, means of course this expression will become same. So I can say v1 is equal to v2, that is the final velocity of both the balls will be same. That means I can say v1 is to v2 is equal to 1 is to 1. That's your answer. Easy, right? Clear? Right, let's move on to the next question, guys. Let's do another question. I think this one. No? Okay, let's take this. Oh shit, can I make this large? Yes, let's take the 83rd question. Right, what has been asked in 83rd has been mentioned that a body A is thrown up vertically from the ground with velocity v naught, and another body b is simultaneously, that is at the same time itself, dropped from a height h. They meet at a height h by 2, that is in mid between value they are meeting. So you are asked what is the velocity, right? Right, one is thrown and another is dropped. So the one which is dropped is having initial velocity 0. Right, the body A is having initially velocity v naught, and you are asked what is the value of that. What of that? No. Okay, how can I take the picture? Okay, what is the value of the velocity of the object which is thrown downwards? Clear? Right. Now let's consider. Okay, the drop will be having 0 velocity. May keep that in mind. We are taking the 83rd question, right? Now let the two bodies A and B respectively meet at a time t, right? And what has been mentioned about the height, they are meeting at the height h2. So let's say this is the height, this is h, capital letter H, right? Now this point from here I am dropping B, and from this point I'm throwing A. Now thrown velocity is v naught, and you are asked what is the velocity of the thrown ball. Dropped, right? So its initial velocity is 0. So this velocity u will be 0. This initial velocity of u is v naught. Clear? Now let's move on. So regarding body A, right? A, that is acceleration, will be minus g. Simple. Now what will be the displacement? S. That's thrown up, so positive, but it is meeting at h by 2. This is the meeting point, so this is h by 2, this is also h by 2, right? So this is meeting point, means how much is the displacement of A? It has traveled h by 2 distance positive, it is moving up, right? So I can write S is equal to ut plus half gt square, right? Now ut, in place of u I will write v naught t minus, right, half gt square. Let's make this as first equation, right? Now regarding body B, this is body A, this is body B. Here also A is minus g, right, but the body B is moving downwards, right? So the displacement is h by 2 itself, but S will be minus h by 2, right? And its initial velocity is 0. So S is equal to ut plus half gt square. I will write it as minus h by 2 is equal to ut, becomes 0, right? Minus half gt square. So minus minus becomes cancel, so it is plus. So h by 2 is equal to half gt square. That is our second expression. You can see the first expression is also for h by 2. Second expression is also for h by 2. So I can equate these two guys so that I can write it as v naught t minus half gt squared is equal to half gt squared. So half gt squared goes over here, so it becomes half plus half plus, right? So v naught t is equal to gt squared. So I can cancel one t, so it becomes v naught is equal to gt, right? Or I can write t is equal to v naught by g. Now I'm going to substitute this value in the first equation, right? There is a t, so h by 2, because you want to find the value of v naught, right? So h by 2, that is in the first equation, is equal to v naught into t. I will write this one is v naught by g minus half gt squared. So this is squared, v naught by g whole squared. So you will get an expression, right, with v naught and h, right? You have to solve this equation, guys. So after solving this equation, you have the value, you will find the value v naught is equal to root gh, right? Calculation, please try to do it by yourself. Clear? This is easy. If you want, I can write here. This one will be v naught squared by g minus, there is a g squared here, there is one g, so one will be cancelled, so it will be half v naught squared by g. So if I reduce half from 1, it will be half v naught squared by g. that is h by 2, right? So 2 cancels, you will get v naught squared is equal to gh, or I can write v naught is equal to root gh. Clear? Simple, right? Now let's move on with the next question, which was it? Again I made a mistake. Let's move on with 82 or 81. Let's move on with the 81 question. How can we solve 81 question? Please read the question when I'm showing it. So a ball is dropped from a high rise platform, that is from a high platform at t is equal to 0, starting from rest. So initial velocity of it is 0. Right. And after 6 seconds, another ball is thrown downwards from the same platform with a velocity or speed v. Two balls meet at t is equal to 18 seconds. What is the value of v? See, they are meeting at t is equal to 80 seconds means one ball, let's say if it is taking 18 seconds to meet, means since the second ball is dropped only after 6 seconds, so it will take only how much? 12 seconds to meet, because it comes easier, right? I will then make you understand. We have done the same with the case of drops of water in a tap case, right? Okay, now let's do that question by drawing a figure. We went a lot downwards. Okay, what was the number? 81's question, right? Yes, 81. Right, so let two balls meet after t seconds, right? And let's say it is at a distance from the x platform, right? Platform, if this is a platform, it is at the distance x they are meeting, right? At the time t is equal to 18. This is ground, okay, right? So for the first ball, initial velocity is 0, right? And let's say it is traveling for 18 seconds. See, this ball had traveled for 18 seconds and it came over here. So the second ball is dropped after 6 seconds, right? So if the first ball has taken 18 seconds to reach here, means second ball has taken only how much? 12 seconds to reach here, because it is dropped after 6 seconds, right? I hope you understood it. So for the first ball, let's move on. H is equal to ut plus half dt squared, right? So here h, displacement is downward. I will write it as minus x is equal to u is 0. Then there is minus, right, half gt squared. And what is t here? 18. Substitute here. You will get the value of x as how much? It's right here itself. 5 into 18 squared. Let's write it as equation itself, because we can equate it, right? So let's write it as x is equal to half 10 into 18 squared. Right, let's write this expression here. Now let's take the second ball's case. Now second ball, initial velocity, it is thrown, right? So let's say its initial velocity is v, and since I told you the time will be 12 seconds for it, and g is minus 10 or minus g I can take, right? Second ball is thrown downwards, right? So it will be minus v, right? Now again displacement is minus x, right? Minus x is equal to minus ut minus half gt squared, right? So I can just neglect every minus here, right? So I can write the expression for it as x is equal to, in place of u I'll write it as vt plus half into 10 into t squared, it is 12 squared, right? Now these both the expression is for x itself, right? So I can I can equate these two guys, so that I will get half 10 into 18 square is equal to Vt plus half 10 into 12 square, right? So how would you cancel or calculate it, guys? See, bring this half, this what here, so half 10 is common for these two guys. Then this 18 squared minus 12 squared is equal to Vt. Right. Now what is a squared minus b squared? Remember, don't do 18 squared and then calculate it, guys. This half into 10 is 5, right? So write 5 outside. Then a minus b, that is 4, not c, right? 6. 18 minus 12. Then 18 plus 12 is 30, right? Is equal to Vt. Right. Now the calculation is easy. In place of t, I can write it as how much? You didn't write here 12 now. You're supposed to write 12 here. Right, so this 6 can cancel 2. This is 15. So 15 into 5 is 75. You will get 5 v velocity as 75 meter per second. Right, because see guys, in velocity time in this vt, I forgot to write 12 here. We substituted t squared in 12 here but forgot to write 12 here. Right, you will get the velocity as 75 meter per second. Clear? Right, now which was the question? Now we have to move to the next question. The question, let's do for the 75th question, guys. A ball is dropped from a roof of tower of height h. The total distance covered by it in the last second of its motion is equal to the distance covered by it in first 3 seconds. What is the value of h? So you have to use the equation for nth second, right? So you're asked from the left if the distance covered in the last second is equal to the distance covered during the first 3 seconds, right? So if that is the condition, what is the height by which it is dropped, right? So let's move on with the question. I think we have written or we are going to do the 75th question. So how we will solve that? Now, initial, because both of them are dropped, I can surely write the initial velocity is 0. Now, let the ball remain in air for t seconds. So, total distance which is covered by the ball in the last second, I will write it as, let's say it is d, right, is equal to u plus g by 2, right? 2n minus 1, let's say it is 2t. Let's write that this is the last second, so it is t, last second minus 1, right? So initial velocity is 0, then it becomes, since the displacement is also minus, g is also minus, I am not considering it, guys. So it is g by 2, so let's write it as 10 by 2, that is 5, right? 2t minus 1, so I can write it as 10t minus 10. That is our last second displacement. That is our first equation, right? Now distance covered by the ball in the first 3 seconds, how can I write that? That is s3, right? That is again u is 0, so I will write it as just half gt squared, right? So that is half 10 and 3 square, so you'll get it as 45, right? So you are told this value and this value, that is dt is equal to, that is the last second displacement is equal to for the first 3 seconds displacement, total displacement during the 3 seconds interval. So I can equate these two equations. I will get 45 is equal to 10t minus 10. So 55 is equal to, right? I think I made a small mistake, guys. This 5t, this is 10t minus 5, no? Sorry. So here I also have to write it as minus. So I will get 50 is equal to 10t. So t is equal to 5 seconds. Right, sorry. There was a small calculation mistake. Right. So I got t is equal to 5 seconds. So I can substitute this value for any height, right? We are asked for h, right? So h is equal to half gt square, right? So that is equal to half g is 10 time for the entire time interval, you will write it as 5, right? That is 125 meter. Yeah, so that is the height of the drop or the platform whatsoever from where the ball is being dropped. Clear? Let's move on with the next question. Let's do the 72 question. Okay. I think this one. No, this one. Let's go to the previous question. Okay, this one. Not a 72 question. Man, right? A man runs at can you see it? Let me make it better. A man runs at a speed of 4 meter per second to overtake a standing bus. Standing bus means that bus doesn't have any velocity, guys. Right, keep that in mind. Right, at a speed of okay. When he is 6 meter behind the door at t is equal to 0, the bus moves forward and continues with a constant acceleration of 1.2 meter per second square. The man shall gain the door at time t equals to, that is when he can overtake it. That's the question, right? Let's move on with the solving the question. Let's read the question. If you want, please guys, if you want to read the question, pause the video, read the question, and then only reach the solving part. Clear? Solve that question, guys. See, let's say this option. Let me take another color. This is our air ground, right? Now this is that man. Okay, okay, and this is our bus, right? Bus door is just, let's say its position here, right? Let's say the position at t is equal to 0, okay? Initial time. Let's say the man's position we are taking to be the origin, right? So that his initial position, let's say xm0, that is his initial position is 0, right? Now the bus door is at 6 meter from here, right? So let's say initially the bus is at rest, right? So the initial position of bus, let's say xb0, that is at t is equal to 0 seconds, right? It is 6 meter, right? This is how I'm taking this one as origin. So initial position of man is 0, initial position of our bus door is 6 meter. Is much clear, right? Now the equation of motion of the man, how can I write the final position of the man? I don't know. What will be the final position of the man? Actually, it will be when he catches the bus. That means the final position of man and the bus will be same, right? That's why, see, the bus was running, right? And this person is running with a constant velocity of 4 meter per second, means his acceleration is 0. Right, so suddenly he's running and he catches the bus. That's what we want to find. What is the time at which he's catching the bus? Right, when he tries to catch the bus with a constant velocity, his final position will be the same as the final position of the bus, because he's inside the bus at that fraction of time, right? So that is a condition. That is, the final position of man should be equal to the final position of the bus, right? This much clear. Now the bus is having, I think, a cancel, right? We are having, the bus is having an acceleration of 1.2 meter per second square. This much is clear, right? Now initial velocity, let's say initial velocity of bus is 0, right? This is also rest, right? Now let's write the equation of motion of our person, that is the person of the man. Final position is equal to initial position, or equal to how, or I can write it as final position minus initial position, right, is equal to initial velocity of the man into time plus half into acceleration of the man into t square. Now the body of the person, or the person is moving with constant velocity, right? So his acceleration becomes 0, so this term becomes 0. Happy? So what is the initial velocity of the man, or the velocity of man is 4 meter per second. So I can write xm is equal to, let's bring this one as this position, but xm naught is at 0, right? Because that is his initial position. Xm naught is equal to 0. So I can write xm is equal to, what is the velocity? 4 into t. That is our expression, or I can write that is the first equation regarding the man, right? Now let's move on with the case of the bus, right? Now in case of bus, let's say xb is the final position of the bus, xb naught is the initial position of the bus, plus ub, now okay, or ub into t plus half ab t square. This is all regarding bus. Now we know xb naught, that is the initial position of the bus is 6 meter, plus initial velocity of the bus is 0. I can write this one as 0, plus half acceleration is given as 1.2 into t squared. So that is our xb. Right, after the person or the man catches the bus, xm will be equal to xb. Right, the final position of both bus as well as that person should be equal. So I can equate the equation as 4t is equal to 6 plus this is 0.6 t squared. Right, from this equation you have to solve. Right, or I can write 0.6 t squared minus 4t. Okay, why did this come? Plus 6 is equal to 0. Right, so when you solve this equation, you will get the value of time as 2.3 second and you will get 4.4 second. So first time gaining will be 2.3 second. The first time the person can catch that bus is at 2.3 seconds. Clear? Easy, right? Now let's move on to the next question, guys. Okay, let's do the which one? Let's do the 70th question. Where does this color come? Now 70th question, can you see? Let's make this large. A particle moves with constant acceleration along a straight line, right, starting from rest. The percentage increase in its displacement during the 4th second compared to that or in the 3rd second. That is, the question is actually easy because, but since the first time you guys are doing the nth second or second question, I'm doing it. Okay, so you're asked. Okay, let's move on. Okay, so you're asked if d3, that was 70th question, I believe. Right, if d3 is the 3rd second displacement and d4 is the 4th second displacement, you are asked change, right? D4 minus d3 percentage, in percentage, that means d4 minus d3, how much is the change in displacement into 100, right? How much is d4 greater than the 3rd second displacement, right? And we take the with respect to initial displacement, right? Now this much clear. Now let us take a be the constant acceleration of that particle, and so nth second displacement you will write it as u plus half a acceleration into 2n minus 1. That is our expression. Now since the particle is starting from the rest, I can write u is equal to 0, right? So dn will be equal to half a 2n minus 1. Right, now what will be d3, 3rd second displacement? It will be half into a into 2 into 3 is 6, 6 minus 1 is 5. So I will write it as 5 by 2a. Right, now what will be d4? d4 will be half into a into 2 into 4 is 8, 8 minus 1 is 7. So it will be 7 by 2a. Now what is d4 minus d3? It is 5 by, sorry, d4 is 7 by 2, right? 7 by 2 a minus 5 by 2a divided by 5 by 2a, right? Clear? So 2 actually cancels out. So you will get around 2 by 5 into 100, right? We have to consider into percentage. You will get around 40%. So 40% change of displacement. Clear? Now guys, for the next live class or live, after live class you are listening to this recorded class, right? So in the live class also you would have done, or I would have done some questions itself. So give importance to numerical questions for the 11th class. Most of the chapter has plenty of numerical questions. Okay,